All right, so today we're going to look at building exponential functions. Okay, so this is kind of picking up where we left off with the last lesson with growth and decay. So you can see that we're still dealing with growth and decay. You can see that we still have growth, we still have decay. And it's still there, but instead of 1 plus r and 1 minus r today, we're calling it b. But it's still the same thing. It's still the same thing. B is just the growth rate. So B is the growth or decay rate. So when it's growth, it's going to be 1 plus R. When it's decay, it's going to be 1 minus R. Okay, that's still there. But I think it'll be a little bit easier for us today to consider it B as opposed to 1 minus R and 1 plus R. It still is there, but I just put a different letter instead of it. And then we've used X mostly last time. Today we're going to use T because we're going to be dealing with time a lot. So we'll use T for time. It'll be some sort of time, hours, minutes, days, weeks, something like that. Okay? A is the initial amount, so how much you start out with. B is the rate of increase or decrease, and so on and so forth. Okay? All right, so let's look at number 1. So a couple things we have to do first. So a person invested $8,800 in an account growing at a rate allowing the money to double every 12 years. So every 12 years, the amount that was in there doubled. Okay? Write a function showing the amount of money in the account after T years, where the annual growth rate can be found from a constant in the function. Round all coefficients in the function to 4 decimal places, okay? Also determine the percentage of growth per year. Okay, so first thing we gotta do is write the function, okay? So we have 2 things. We have T is time. In this case, it's gonna be years, because we have years. F of T is gonna be the amount, or money. Okay, so the first thing I'm going to do is I'm going to draw a little picture here. I'm going to draw a little table just to see what's going on. So T is the time, right? Money, or the amount, we'll call it A, which is just the amount, right? So it says the person invested $8,800, right? So that means at the initial, they had $8,800 in their account. It doubles every 12 years. So in 12 years, it's going to double. Okay? So double, let's see. Okay, so it's going to double every 12 years. So let's see. 8,800 times 2, 17,600. And then in another 12 years, it's going to double again. Okay? So in 12 years, it's going to be 17,600. And in another 12 years, it's going to be 35,200. And so on and so forth. Okay, that's the idea. So they want us to write a function. Okay, well, we're going to use this guy here to write our function. So the first thing we need is A. A is the initial amount. Initial amounts. Well, that's 8,800. That's how much the person started out with, right? And then we're going to need to find the growth rate. Obviously, it's a growth rate because the money's getting bigger. So it's going to be a growth. So it's going to be this guy here for this problem. And we're not going to use R. I'm going to use T. So T is going to go up here. Okay. Oops. Okay. Oops. All right. So now, what we have to figure out is the growth rate, right? When we know it's growth, so we're going to circle growth. So we got to figure out the growth rate. So far, we have f of t equals 8,800 t. And we don't know b right now. We don't know what b is. So we're going to just keep b as b right now. We're going to solve for b. So what I'm going to do is I'm going to use another point that I have on my graph. On my table, sorry. Okay? So I've already used this point because that's the initial. That guy is reflected there. But I haven't used one of these guys. So I can use either one of them. I'll just use this one here. You could use the other one, 24 and 35,200, but I'll just use this one here. So what I'm going to do is I'm going to plug in 12 for t, because that's the time, right? In 12 years, you're going to have, and that's the amount, 17,600. So 17,600 equals 8,800. B is still B, because I don't know B. But now I'm plugging in 12 because in 12 years. So what I'm going to do here is I'm going to solve for B. Okay, I'm going to solve for B. So draw my line down here. First thing I'm going to do is divide. I'm going to divide by 8,800. 8,800 divided by itself makes 1. And then 17,600 divided by 8,800 is 2. So this is going to be 2. Bring down what I haven't used. Right? Okay, so I still want to solve for b, so it's to the 12th power. The opposite of 12th power is 12th root. So I got to take the 12th root of both sides. So that'll make b by itself. Because 12th root, 12th to the 12th power just is b. Because it's really, this means 12 over 12, right? That's just b to the first, which is that guy right there. Okay, so I'm going to go to my calculator and figure out what 12th root of 2 is. So I'm going to go 12th root, positive 2. So remember, it said in the directions it wants me to go 4 places past the decimal. So 1.059, and then the 4 is going to go up since the 6 behind it is bigger than 5. So 1.0595. Okay, that is B. Okay, so I have my function here. Now all I have to determine is rate of increase. Well, we know it's increasing because it's growth. So increase and growth go together. So now I have to find the percent. Well, let's go back to where we started, right? We said growth is 1 plus r, right? 1 plus r. So now what I'm going to do is I'm going to put this guy down there, right? Because we know that b equals 1 plus r. Well, we know what b is now. We know b is 1.0595. So now what we're going to do is we're going to solve for r. And then we have to change it to a decimal. So I'm going to subtract, or sorry, percent. So when I subtract, I get 0.0595 equals r. That is r, but they want the percent. So now what you're going to do is you're going to multiply that times 100. Multiply this guy times 100, and you'll get 5.95%. So it was a growth, and the growth was 5.95% every year. Okay? All right. All right, let's look at number 2. Number 2 is the same type of problem, but the only difference is it's talking about a radioactive isotope and not money. But they grow similarly. They grow and they decay similarly. So element X is a radioactive isotope such that every 25 years its mass decreases by half. So whatever it was before, it just cuts in half, right? So given that the initial mass, so the initial amount, right? The initial amount is 50, so that guy's going to go there. Write a function showing the mass of the sample after t years, where the annual decay rate can be found from a constant in the function. Round all coefficients in the function to 4 decimal places, and then the percent rate of decay per year. So again, it's going to be decay, and that means it's going to decrease. Okay? All right, so let's set up a table. So t, so this is going to be t. T is years, and then f of t is going to be mass. Okay, so let's make a little table here. So we have t and we have m. I'll put m for mass. Or sorry, f of t. It's mass, but we called it f of t, so I want to stay the same, f of t. Okay? So at the initial, it was 50 milligrams. Every 25 years, right, it's going to cut in half. So that means in 25 years, it'll have 25 milligrams left. And in another 25 years, it's going to have half of that, which is 12.5. And so on and so forth. Okay, so let's write down what we have. We have f of t equals 50 times b, right? To the t power. So now what I'm going to do is I'm going to use one of my dots, one of my points. I already used this guy for that guy, right? So now I'm going to use either one of these two guys. I'll use 25 and 25. So 25 is t, and 25 is also f of t. Okay, so what does that look like? It looks like this, 25 equals 50 b to the 25 power. Now I have to solve for b like I did in the last problem. Okay, first thing I'm going to do is divide by 50. 25 divided by 50 is 1/2, because 25 is half of 50. That's a 1. So now I have b to the 25th. So the opposite is a root. In this case, the 25th power, the 25th root. Okay, so that's going to make just b by itself. So now I got to go to my calculator. I'm going to go to the 25th root of 1 divided by 2. Okay. Enter. Remember, I'm going to go 4 spaces past the decimal. So this guy here, this guy in the gray. So 0.9726. The 6 is going to go up since the 5 behind it is bigger. Okay, so it's going to be 0.9727. 9727. That's going to be here. That's going to be B. That's our decay rate, right? It's a decay this time. Okay, so now our last thing is to find the percent. Well, again, this is decay, right? We said decay is the same thing as 1 minus r. So I'm just going to rewrite this equation, but with our b. Okay, because b equals 1 minus r, right? So we know b is 0.9727, and that equals 1 minus r. So I'm going to subtract 1. Since it's positive, I got a minus 1 from both sides. So you're going to get negative 0. Let's see. 0.9727 minus 1, negative 0.0273. Okay, but it's still negative 1r, so we got to divide by negative 1. All that does is make it positive. R always has to be positive. So 0.0273. So the last thing we got to do is multiply by 100. When we do that, we get 2.73%. So it's decaying by 2.73, or it's decreasing by 2.73% every year to make that work. Okay. All right, so the last two are very similar, but we just have to answer a question. So like number 3. The population of rabbits on an island is growing exponentially. In the year 2005, the population was 6,900, and by the 2012, the population had gotten bigger to 1,350. Predict the population in 2005 or 2015. Okay, so let's kind of draw a picture here. So we got T. So T is years again, right, for this one. F of T is going to be the number of rabbits, because that's what we have to predict, the number of rabbits. So F of T. Okay. So T, so it says in 2005. Since that's the earliest year we have, we'll call that the initial. And then it said if in 2012, well, 2012 is 7 years later, there was 13,500 rabbits. So they want us to know how many there would be in 2015. Well, 2015 is 10 years since the initial. So that's what we got to come up with. We got to figure out what that question mark is. Okay, so just like the last one, we're going to build our function. So the initial amount is 6,900. Okay, so 6,900 is my initial amount. That's going to go here. I don't know what B is. Again, I don't know what B is. I don't know what the decay or the growth rate. It's going to be a growth, right? Growth rate. I don't know what the growth rate is. I just know it's going to grow. So just like on the last one, I'm going to use a point that I already know. I'm going to use this guy here. That guy is going to be T. That guy is going to be F of T. So 13,500 equals 6,900. Oops, not T power, it is the 7th power. Use a different color, there we go. Okay, so now I'm going to solve. Okay, so I'm going to divide by 6,900. So I'm going to go to my calculator, 13,500, let's see, 13,500 divided by 6,900. Okay, so it's a decimal, but you can see the decimal keeps going. 1.95956252217. It keeps going and going. It actually doesn't stop there. It keeps going. I don't want to use that. I'm going to use the fraction, 45 over 23. That's the reduced fraction. So I'm going to say 45 over 23. Yep. Okay. It's the same thing, just not a long decimal. I don't want to round until the very end. Okay. So, and then we take the 7th root of both sides. To undo that. So then we go back. Now, I need the 7th root. Okay. So the 7th root, and then I need the previous answer. I'm just going to say previous answer because that was 45 over 23. It's that guy there. Okay. 1.10062, so on and so forth. Okay, so B is approximately 1.00 628. 1.10, sorry, 1.10628. That's B. Okay, so now I know what the growth rate is. 1.10628 to the t power. Okay, so now that I know that, all I got to do is put in 10 for years, and I got my answer. Okay, so I got 1.1000628 to the 10th power. Now I have that. So watch, when I go back to do this, I'm going to do exactly what it says. 6900 parentheses, but I'm not going to use, I'm going to use the previous answer. I don't want to, I want to use the unrounded one. Close it, raise it to the 10th power. There we go. So it's 17,999.30654. And again, it keeps going. They want us to round though. In this problem here, they say round to the nearest whole number. Okay. So the nearest whole number is either stay where you're at or go up one. Well, if I go up one, it's going to be 18,000. So let's see, do I need to? But if you look, it's 17,999.3. That's not enough to go up. So it's actually going to stay at 17,999. And this were rabbits in 2015. Okay. All right. Last one. Tristan purchased a new car for the year 2000 for $22,800. The value of the car has been depreciating. Depreciating means losing value, decay, exponentially at a constant rate. If the value of the car was $10,400 in 2006, then what would be the predicted value in 2016? Okay, so let's make a table. So there's two things here. T is going to be time again in years. F of t is going to be how much it's worth, the value. The value is in money, dollars, okay? So we'll say t, f of t. So initially in 2000, he bought it for $2,280. And then in 2006, 6 years later, the car was worth less. They want to know in 16. So 2016 is 16 years away. 16 years from when Tristan initially bought it. Okay, so let's set up. Initial amount is 2,280. We don't know what B is. We got to find B before I can plug in 16, right? At the end, I just want to plug in. My goal in the end is to plug in 16 here and get my answer. But until I find B, I can't do that. Okay. Okay. So I'm going to use one of my other points like I did before. So I'll use 10,400 equals 22,800 times B. And then this 10,400 was in year 6. Okay, so like I've done before, I'm going to divide. So you get B to the 6 equals, okay, let me go to my calculator. So 10,400 divided by 22,800. So again, it's a long decimal. I'm not going to use that. I'm just going to use the reduced fraction, 26 over 57. 26 over 57. Okay. Take the 6th root, and that's going to be B. But we're gonna round it, so that's when you see the wavy little lines like that. That means we have to round it. I know it's not going to be a whole number. So let's go back to here. The 6th root of the previous answer, 0.87737. Okay, 77. Okay. Well, it's a decay. It's below 1. It should be B should be below 1 because it's depreciating. If it's B is above 1, it's growing. If B is below 1, it's decaying. If B is 1, it's not growing at all. It's staying the same. Okay? All right, so now, last thing we're going to do is, so now we have our function we can use. Function is just anything you can plug numbers into. So formula. Okay? So now that we know what B is 0.87737 to the t power. Okay, so now I plug in 16 like I wanted to. Okay, so I'm going to go back to my, again, so now, what was it? 22,800, that's the initial amount. So 22,800 parentheses. But I don't want to round. I want to use my previous answer to the 16th power. Okay, so it's $2,811.02. So let's see, they want me to round to the nearest dollar. So the nearest dollar is the ones. So 2,811. 2,811. value of car in 2016. Okay.